Hello everyone, I hope that you're doing well and good. In the previous video, PySpark explained, I have talked about most of the concepts related to PySpark, but I noticed that I forgot to mention about the window functions. So this video is specifically going to be about that. So before watching this video, please make sure that you know all the concepts that are related to the PySpark and like before knowing PySpark, you should also know a good amount of SQL and Python. So that is even prerequisite to that. But in case you are watching this video, I take that you are good at with the SQL, Python, and a decent with PySpark. So let me just go on to explain. So in the previous video, I have discussed up until here, where I have explained like multiple joins and that output we are getting and also the count we have taken. Now from PySpark.sql.window, we import window with W capital. Please do remember that the W is capital. And then now what we are going to do is if you, in case you remember the salaries table, the salaries we were having. Let me just go to the sequel and just brief you about that. So we are on the sample superstore, and I suppose we should go to the employees table database and yeah, select salary from salaries order. Just let's execute the first query. Employee salary from salaries and order by employee ascending and salary descending. So per employee, we are having salaries and an employee is having multiple salaries. So, but the salaries I have ordered it by descending order. So that's the first thing. Now I have created a row number. I have created a window function. I hope that you are aware of about the window function in SQL before watching this video. So if I execute this query, then you can observe that it has specified the row number per employee number, so 1 2 3 so on, up until wherever we have the last employee number, it will give the row number to that, because we have partitioned it by the employee number. Yeah, so let me just also explain you the difference between the partition by and order by. Let's say you have some column value and that column value is repeating in itself, and you want to do some aggregate of that value, then you can choose to do group by, or else you can choose to do window function over partition by. In case you do partition by, then that will the output that you will get will be the aggregation, will be just like group by. Let's say I am taking max or average of salaries from employee. Let's say select employee number, comma, average of salary from salaries group by employee number. So if I execute this one, you can observe for every employee number I have the average salary. I haven't rounded off to the perfect decimal place or whatever decimal place I want. I can do that if I want. But the similar syntax I can also write by select average of salary over partition by PARTITION by employee number, order by, let's say I just keep it by this one. In the first scenario, I'm not ordering it by anything. Now if I execute this from the table, yes. Now if I execute this one, you can observe that my average salary I'm getting, but it is getting replicated, which I don't want. So I will just write distinct here, distinct. Now if I execute this one, yep, and you can see the name is too big. I can give the aliases as with salary just to make it even better. Yeah, and this one and the above one will give me the same output, but the way in which I've executed it has different. In the first one I've used group by, and the second one I'm using the partition by logic. Now let's say you want to do another thing, which is after doing partition by you also want to do order by salary. In that case, uh, I am also taking row number because I want to show it. So in that case, what I can do, I can execute this one, and it will just give me the value of employee number, salary, and row in descending order because I have specified in order by descending, DESC. If I didn't specify it, it is by default take it as ascending. And another thing that you need to remember is that in case you do the over partition by, then it automatically sorted by ascending. So in this scenario, it automatically sorted it by ascending. If I execute this one, so that is in ascending order, right? So these are the major basic concepts of window functions. Now I just want to see from this table. Uh, there is a concept of with CTE and subquery. I hope that you are already aware of it because the CTE and the subquery is the same logic. So now if I execute this one, I'm just taking wherever the row number is 3. So for the employee number one, I'm taking the third highest salary. Number two, third highest salary. So I'm taking third highest salary for each and every employee in this scenario. And this with CT statement will also give me the same output, same number of rows, right? So that's the logic that we are trying to implement in PySpark. Now, if I minimize it, go back to the PySpark. Now using PySpark window functions. So window functions we import from PySpark.sql.window, import window, and I can assign that to a variable, or I may not assign that to a variable depending on my, like, if I want to I can also write entire thing here as well. Now the syntax is window.partition by dot order by, the same scenario in the same order of execution. Just remember that the partition by comes first, then order by comes in the second in window functions, both in SQL and Python. Now I'm partitioning it by the employee number and ordering it by salary. I'm taking the salaries with column row number. Row number is the function that we are taking over dot w. W is the this window function that we have specified above here. Then I'm taking the forward backslash to make the select statement in the next line, selecting employee number, salary, and the row number from yeah, where the row number is equal to 3. So I'm also specifying where as well and sorting it by ascending employee number. So in the SQL, if you do Windows function, then you don't have to provide sort. It is by default sorted. But in PySpark, you have to provide sort. So that's another thing that I have noticed while making this video. So which you need to remember. Okay, now if I execute this query, it will give me this output, which is the same output that we got there. We can just cross check it by like 10001 has having 85097, and 10001 is having 85097. So same output and same number of rows. We can take the count of it and check, but I'm not doing it as of now. So now moving on. Now we have df.show. Df, if you remember the sample superstore data that we have taken and that we have done some transformations as well. So which from the previous video, I hope that you have watched the previous video before watching this video. So now to continue, I have created a view or create or replace a temporary view named of df, named by the df and sql window. And now I am trying to do partition by sum of sales. Now this query, let's go back to here, concepts explained, and this you will find in the video that I have made, SQL advanced concisely explained. Yeah, that video, SQL advanced concisely explained. Now moving on, I have to use the sample superstore database. Then I have to execute this query. Now, if you may notice, if I execute this query, then this is replicating, which I do not want. So that is why I have taken distinct here. And the same distinct functionality, we also have to execute in that our PySpark as well, which you will notice. So I have taken distinct of year and month, and I have taken simple partition by year and month. So it is just simply doing me the giving me the partition by the order date of year and order date of month, rounding off to the two decimal places because I wanted to do that as sum of sales, which is the aliases I provided from the superstore. If I execute this query, that's the output that I'm getting. So this output is just equal to the group by. If we do perform group by, then also we will just get this output, and I can also do it by just executing this one. So this one I did by using group by, and I'm getting the same output. I have taken another column which is the month number because I have to do some calculation based on that, and calculation on the basis of, let's say for example, I'll show you, because in SQL if I wanted to implement it I have to order it by month number, or even in the PySpark as well. Now, moving on. So that's our sum of sales. Now, if we do the order by of year and month, and if we execute this one, then that will give us the running total. So running total is basically nothing but the sum of sales of first, then added to the second, then was first and second added to the third, and all the three added to the fourth. So on, so on. We will keep on adding. That is why it is called running total, and that's the output that we will get. Okay. Now same logic we will implement in the PySpark as well. Let's go back to the PySpark. We are back here. So now I have taken the same query. Now let's say another thing that you need to remember. Let's say that you want to provide a column with spaces and you don't know how you would provide an SQL syntax for that. So in SQL, when you have to provide in MySQL, not SQL Server, that is a different syntax. In MySQL, in case you want to do some query execution while having the column which is having space in it, then you have to make that this is not single quotes. If you see closely, it is not a single quote, and this is the number that is below execute key and on the left side of the number one. You will find that below the tilde is the sign, this sign is tilde, this sign is tilde, not this sign, this sign. Yeah, the curly sign is tilde. Okay, now so that is our order date. And we have to, because we were having spaces in it, I have to specify it like that. Now, if I execute this query, I'm getting year, month number, sum of sales. And you may notice that I have to sort it on the basis of year and the month number. Otherwise, it will just give me the random thing which I don't like, which nobody likes. I don't know why PySpark does that, but it does that. Okay, and so yeah, so that is giving the output that we want. Now we are trying to implement the same output in our PySpark. Now I have taken the partition by on the basis of year and month, the same as I did before, and that will just give me the output which is similar to the group by. And I have also taken the month number as well. Now, if you may notice, I haven't partitioned it by the this month of OD, which is in Jan, Feb, Feb. If I try to do it by that, then the first value that I will get is April because it starts with the A, which I don't want. I want it in the order of the value that we are getting month wise. And after that, I also want that the whatever we do in that, let's say, partition by, whatever partitioning we do, we want on the basis of our January, February based on the year. So that's the order, and we also have to sort it out. So like you need to experiment a little bit to find out all things that you can do with it. Now I have taken the round of sum of sales over, and you can see that over is inculcated with the sum of sales because over clause is always inculcated with the aggregate. Please do remember that. Okay. Now moving on to the next line, I have selected the required columns that we require and sum of sales because that df is having too many columns and I don't want to specify all the columns, so that is why. And you can also see that I have to provide distinct. If I don't take distinct, then this value will repeat like it did before, which we do not want. So that is why we have taken distinct, and we also have sorted it, and then we are showing it. So lots of execution is happening here. I know it is a little bit complex, but just because it is complex, that is why I'm explaining it. Now, moving on. Okay, now we did the sum of sales logic. Now, that's the same logic that we did above, I suppose. Yep, that's the same logic we did above. But in this scenario, I have taken it, assigned it a variable df sum of sales because I might have want to make df sum of sales create or replace temporary view. So I want to execute it here. So that is why I have taken it. So now what do we have? We have running total. Now we are trying to perform running total. We have taken the statement distinct of order date from sum of sales, and we have performed the running total of order date. Yes, 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 yes. So this is df SQL window. So df SQL window, I think I have provided, yeah, so that's the same data frame. Nothing too much to worry about. It is I have taken the same data frame, and I performed the running total. And you can see that I have taken year, month number, running total, and I have also rounded off to the two decimal places. In this scenario, we also take so aggregation. As I told, when we do the aggregation, then we have to take the over clause in window function, and then we have to round it off. Now, moving on, we also have sorted it on the basis of year and month number. So that is what we have to do, and that is what we did. All that to get the running total. Yeah. And similar logic we are going to implement using PySpark as well. Same thing again, but the only difference in this one is it is order by in the running total. But in case you want to do the sum of sales, then it is partition by because it is a basic group by. It acts like a group by. Now, moving on. So that is the running total we did. After that, we will do running total per year. So per year, we will partition it by year and order it by month. So in that scenario, what happens is this query executes and the running total will happen. So this plus this plus so on to 12. And after it reaches 12, it will reset itself and start again. So that's the running total per year. And in this scenario, we have to take partition by of year date and order by of a month of order date. So let's say you want to do order by. In order by, always we do order by when we have to perform rolling. Remember? Done. Partition by, we always do when we have to do group by. Remember? That is also done. When we do partition by and order by together, then we are specifying a partition on the basis of which we want to do some running total. So in this scenario, we want to do running total on the basis of year. So for the year itself, the running total will implement. But once the year ends and starts over in January, it will reset itself and start to execute again. And if we cross check our output of this one to the output that we are getting in our MySQL, then the output is same because I have just cross verified it. Let's execute this one. Now you can see that we have 14 first. Oh, maybe the data is different or maybe not. Let's see. Go back. PySpark. In this one we have 13 and this one we have 14, but the data values that we are having is same. So it is starting with the 14161, 14161. Yeah, no worries. And in this one, I suppose the data will be up to 17, and that one the data would from 13 to 16. Doesn't matter. So from up till December, it was 4817 and then 18085. Similarly, if we go back, for December 4817 and 18085. So same values. You don't have to worry about it. Now, moving on. We have did the same logic. First we did the partition by, then we did the order by. So that's how we do it. And that's how we also do it in the PySpark. And also remember that distinct is being used and sort is also being used in the PySpark. Now, that's most of it. I'm taking everything from the sum of sales, which I have created above, I suppose. Yes, I have created sum of sales above, which is basically this table, which is basically the partition by or the group by thing. Now I am using this and I'm looking at everything, so that's good. And on the basis of that, I am trying to do the rolling, and I was able to do that using SQL. But another thing that we need to cover is rolling. Now let's go back. Let's go back. Now we are having this table, sum of sales, and we are trying to execute it whenever we are performing rolling. And rolling is nothing but it is simply ordering by meaning that we are trying to do the rolling total. Yeah, not rolling total, the running total in the rolling itself, but not on the base. We are not partitioning it by any value as such, but we are partitioning it by a specified rolling value. What I mean to say is that if I execute the rolling of two preceding and the current row, then three values will be getting aggregated. So this plus this plus this. When we move down to this, so the previous two plus the current. If we move down to this, then previous two plus the current. So the rows between two preceding and the current row, and we can also do the five preceding and current. We can take the, it will take six values since it is five preceding and current. So in the two preceding and current, it will take three, and five preceding and current, it will take six. Just plus one. Do remember that as well. And so that's the logic of rolling. I tried to execute it the same logic of rolling using PySpark, but I wasn't successful. But we can see it is by, let's say, for example, rolling um, PySpark. Wow, let's do this. Rolling in PySpark, Stack Overflow. We can see that they say that range between we have to take 3 days and zero, minus 3 days and zero. So three preceding and the current. So it is the same logic, but the catch is that it works on a timestamp. So if it works on a timestamp, then I will not be able, if it should be the date value for me to do that. If it is not a date value, I cannot do it. So that is why I haven't done it. Anyhow, if you please do try to do it if you can. Now moving on to the lead lag. So the lead lag concept. First of all, I need to explain the concept. So what is a lead and what is a lag? Let's go back to the SQL and we go down and we see this table. Let's go and view this table. This table we have customer ID, then order ID and order date. And that order date, I have like order it by the customer ID first. So it is repeating 5 times. Then this is the AA10375 and this is 15. So and the order date is like this. And I have also ordered the order date by ascending such that it remains ascending. Now let's say for example I want to do a lead on it or a lag on it. A lead would be that my next value would come on this place. So that would be lead. And a lag would be my this value would go to the next place. Now if I simply execute the lead and lag, you may observe that this value in the next state, which is the lead, will go up, and in the lag this value, which is the current, will go down. As simple as that for the values that we have taken in the partition by. So for only the customer ID of that sort. Now over it I can also perform some calculations as well. Now let me show you the second table. I have made a video on it, but just in case. So the previous date I have taken, we can also specify it by 1 or by 2, whatever the value that we want. We by default it is by 1 places. We can do lead or lag. Okay. Now we can also perform some arithmetic operations on it. Let's say we want to subtract date, we can also do that, and we get the output of difference as well. So these are the functionalities that we can implement. I haven't implemented the, after doing lead lag, I haven't basically do the with column and did the date subtraction, but we can do that. You may also try to do that. All right, now moving back to the PySpark. PySpark, we can see and observe that I have taken specific column from that DF and I have taken the distinct of it and sorted it basically and put it in a table which I want to do on the lead lag, which I want to do lead lag on. Right. Moving on, I did the lead lag here. I take the window function, then partition it by the customer ID and order it by the order date. So the same concept that we did before, the same thing and the same numbers, everything is same. With column, lead lag, lag is this and over W. W is nothing but the window function that we have created. Right? Oh, let's just try me. Let me just try. If I take a small W, does it execute? Aha, it doesn't execute. So it only works with the capital W. Yeah. So that is another thing that we have learned. And now you have to be careful about that. The partition by B is capital and the order by B is capital. And this is the basically camel casing. Camel casing is nothing but it starts with the small and whatever the next word is, it will start with the capital letter. If you go down here, create or replace temporary view, this is also camel casing. The first is small, and the whatever the next word is, the create or is the next word, replace is the next word, temporary is the next word, and the view is the next word. So camel casing. Yeah. So I think I have explained everything. And the lead we can also specify by the order date and one places, and we can also take it by two places if we want, but I just want to do it by one places. And similarly, we can create a temporary view of the table that we want to create from that df lead lag, which we created above here, which we created from um, here, I suppose, not here, lead lag here, this table we created, and the output we are showing of the lead as well as that of lag. And here as well you can see that with column specification I can do it one time, then I can take that as entire table and I can do it again with column. Similarly, in the case of joins as well, you can do joins like that as well, one after the other, and that is for line break and separation. So I think I was able to explain this entire scenario to you. It took me quite some time and it has a lot of things to be explained, but yeah, I was able to do it and I hope you liked it and I hope you were able to understand it. So thanks a lot for watching this video. Now you are basically a professional PySpark developer. Great. Now, bye bye.